Hello everyone, this is another video on quantum mechanics, and this one we'll be revising some stuff that we have studied for our GATE exam. Okay, mainly in this class I will be revising perturbation, WKB approximation, and scattering theory. These are the important parts. There are 2 more questions come usually, so better we revise this stuff. Okay, so we will start with perturbation. Okay. So how the question will be? Question will be here for like first order perturbation will be asked of ground state or first excited, second excited, anything. What do you have to do? We have to find the expectation value of the perturbation that is given. Okay. If we can find the expectation value of the perturbation, then we can solve the question. Right? For example, 1D box will be given. Okay, psi will be given root over of 2 by a sine pi x by a. Okay. Then your perturbation will be something like given like x square, something like that. So suppose example. So how will you calculate it? So en1 will be expectation value h dash. That means minus what minus l to l or whatever the limit given here. Okay, minus a to a or something like that, whatever. Psi star h dash sine dx. Okay, so we'll put the value here 2 by a sine pi x by a. H dash is x square root over of 2 by a sine pi x by a dx integration minus a to a. Yeah. So this will be your the way to find perturbation. Right? Okay. We'll do some examples through which we will try to understand. Instead of going to the theory, we'll try to understand the example. Suppose the diagram is given like this. Hmm. This is 0 0. This is a V naught potential 2L V naught. Okay. This is your 2L 0. So this is an asymmetric potential. Okay. It's an asymmetric potential. This is along x-axis. This is a y-axis. Yeah. So you are asked the first order perturbation. Okay. So how to do this? See, first of all, how to get the equation of perturbed Hamiltonian. The equation of perturbed Hamiltonian is the equation of the straight line. Okay. Equation of the straight line. Got it? So equation of the straight line is what we know: y minus y1 by x minus x1 is equal to y2 minus y1 by x2 minus x1. That is the equation of a straight line. So I can write y minus y1. Y1 is how much? 0. Divided by x minus x1 is 0. Y2 is v naught minus y1 is 0. Divided by x2 is 2l minus x1 is 0. So this becomes y by x is equal to v naught by 2l. Okay, so the equation is what? Equation is what? Y is equal to v naught by 2l into x. So this is your y. This is the and the y is your actually perturbation. H dash is equal to I can write v naught by 2l into x. Okay. If that's the case, then what is the what will be your what first order correction in the energy? First order correction in the energy will be what? En1 is equal to perturbation expectation value times v naught by 2l expectation value of x. Okay, that means what v naught by 12 expectation value of x is what? For an asymmetric potential, expectation value of x is length by 2. Okay, that will be v naught by 12 into 12 by 2. That is this is L. So the answer is v naught. Or what? What to do? Oh, there's still 2 there. So v naught by 2 is the answer. Hope you understood. Yeah. Yeah. For symmetric potential, suppose the symmetric potential is like what? Suppose this is your symmetric potential minus L to L. This is the origin. Okay, this is the origin. So symmetric potential expectation value is zero, average value, because in left left, L to right, so average value is zero. This is asymmetric. Alright, got it. Next question. Next question will be yeah, L V naught, this is V naught, L to L. So we have to find what uh, first order correction. Before that, we need to find what H dash. Okay. So H dash here, if you see, we have two different lines. So we can say H dash you have to find for 0 to L. First of all, 0 to L, one H dash, that will be what? Um, so what? This equational line we have to find out. Another is what? L to 2L. L to 2L. And this is your what? X is how much? No, not X here. Y. Y is how much? V. Okay. So if you see equation, this equation of line will be y minus y1 by x minus x1 is equal to y2 minus y1 divided by x2 minus, okay, y minus y1. So y minus y1 is 0, x minus 0, y2 is v naught minus 0, l minus 0. Okay, so y by x is equal to v naught by l. So y is equal to v naught x by l. Y is equal to v naught x by l. Okay. So if you see, this is your perturbation between 0 to x to l. So this is the perturbation is v naught x by l. So your E n1 would be how much? H dash, that will be v naught by l x. That will be v naught by l into l by 2. So v naught by 2. Okay, this is v naught by 2. What is the other perturbation? That is simply y is equal to v naught. That means h dash is equal to v naught. We need to calculate it. So the second one is v naught. So the total perturbation is how much? Total perturbation total will be 3 v naught by 2. Okay. Yeah. Okay. Now let's come to symmetric potential. Let's come to symmetric potential. Symmetric potential, what will happen? This is a potential suppose minus a by 2 to a by 2 0. Okay, this is v naught. So here your first row correction will be en1 is equal to strength of perturbation into length of perturbation, length of perturbation by length of the wall, length of the wall. Okay, so here strength of perturbation is V naught into length of perturbation is what? A, isn't it? Sorry, this is the perturbation. The perturbation length is A by 2. The length of the whole wall is minus A by 2, A by 2. That means A. Okay, so V naught by 2 is the answer. Okay, is that alright? Yeah. Okay. This is actually applicable when, okay, right? This trick is applicable only when constant perturbation is in either side of 0 or middle point. Okay, but it's not applicable. It's not applicable if x is 0 is within the perturbation. Is within the perturbation. Is that alright? Yeah. Okay. So let's do a question, and if it is within the perturbation, what will happen? We'll see. Okay. If it is within the perturbation, how will we solve it? So minus a to n is okay. Minus a by 2 to a by 2 0 v naught. Okay. So how to solve this one? First of all, ground state. Ground state will be 2 by length is 2a. Okay. Cos pi x by 2a. This is the ground state. Yeah. And why I wrote cos? Because we know psi n is equal to root over of 2 by L cos n pi x by 2a L whatever if n is odd. Okay, because this one we can say 2a. Okay, and root over 2 by 2a sin n pi x by 2a if n is L. Remember this, if this is odd it's because this is even, this is sine. Okay, so here if you see the ground state is what? Ground state is root over 2 by 2a cos pi x by 2a. Okay, cos pi x by 2a. So your ground like correction would be, what is the correction? Integration, what will be, what is the perturbation limit? Minus a by 2 to a by 2 is the perturbation, that is v. So minus a by 2 to a by 2 root over 2 by a cos pi x by 2a into v, or v naught, what is v naught? V naught root over 2 by a cos pi x by 2a dx. So v naught into 2 by a minus a by 2 to a by 2 cos square pi x by 2a dx. So 2 v naught by a minus a by 2 to a by 2 1 plus cos 2 pi x by 2a whole divided by 2 dx. Okay. So 2v naught by a 2a minus a by 2 to a by 2. Sorry, let's start with the integration x plus sine pi x by a whole divided by pi by a minus a by 2 to a by 2. Okay, v naught by a by 2 plus sine pi by 2 by pi by a minus minus of a by 2 minus sine pi by 2 by pi by a. Okay, so v naught by a by 2 plus a by pi minus minus plus a by 2 plus a by pi. Okay, so this will give me v naught by a 2a by 2 plus 2a by a. Okay, so v naught 1 plus, is that alright? 1 plus 2 by 1. Or did I do a mistake? Just let me know. I take the 2v out to 1 by 2 plus 1 by 1. Same thing. Another question. Suppose this is a perturbation. Minus a to a is the perturbation. 0 is this one. Minus 3a to 3a. V naught. Okay. So again, how to solve this? Again, psi gs is how much? Root over of 2 by 6a cos ground state pi x by 6a. Okay. Perturbation is V naught. So first order energy correction minus a to a 2 by 6a cos pi x by a 6a into V naught into 2 by 6a cos pi x by 6a. That is V naught into 2 by 6a minus a to a cos square pi x by 6a. See, cos square is an even function. So when there is an even function inside, integration of even function, if the limit is like this, I can simply do it as 0 to a by 2 even, and this is 2. Okay, so I can do it here. V naught into 2 by 6a into 2, 0 to a cos square 6 pi x by 6a dx. So 4 V naught by 6a 0 to a 1 plus cos 2 pi x by 6a whole divided by 2 dx. Okay, so 2v naught by 3a 2 into 2v naught by 3a this is x plus sine 2 pi x by 6a whole divided by 2 pi 6a integration 0 to a. So V naught by 3a plus sine pi by 3 by pi by 3a minus 0. Yeah. So that can be V naught by 3a plus and pi by 3 is root 3 by 2. This is 3a by pi. So V naught by 3 1 plus 3 root 3 by 2. That will be answer. Got it? Yeah. Next question. This is the perturbation minus a0. This is a v naught. Okay. This is 0. This is plus a. Infinite, infinite. So again, same thing. So what will you do? How will you start it? First of all, perturbation, we know y minus y1 by x minus x1. The equation of line is the perturbation. y2 minus y1 by x2 minus x1. Y minus 0y x minus minus a is equal to v naught minus 0 by a minus minus a. So y minus 0 by x plus a is equal to v naught by 2a. Okay, so y is equal to x plus a by 2a into v naught. Okay, this is your this is the equation. Because you can write it this way: v naught by 2a x plus a. Okay, this is the perturbation. The perturbation is just equal to v naught by 2a x plus a. So ground state correction, energy correction. Okay, minus ground state energy correction is what? Like here, like this. So v naught by 2a x plus a. V naught by 2a comes out x plus a. Okay. So v naught by 2a into x plus this one just will remain a. Okay. V naught by 2a into a. Now see, this is a symmetric potential, right? Minus a to a. So symmetric potential, the expectation value of x will become what? 0. So this is 0 plus v naught by 2. I'm sure you can get it. Got it? The next question. This question usually comes in exam. Here v is equal to 0, e3. Here e2 minus v here. Here v plus v0. E1. Okay. So here in every case we have to find out this is E1, this is E2, E3. So you have to find out which one is greater, which one is less. Okay. That's what the thing is. So here if you see, this is actually, so first one, H1 dash is equal to, we can see V naught into what? What is the length of, like this length, A by 3 by, whole length is A. Okay. So V naught by 3. Now this one, H dash. So this one I can say E1 The ground state can be pi square h cut square by 2ms square plus v naught by 2. Right? Now h2 dash. H2 dash is minus v naught into, again, this is minus v naught because this is downwards. Okay, so minus v naught by 3. So E2 dash, so E2 will be pi square h cut square by 2ms square minus v naught by 3, isn't it? Okay, now h3 dash is 0. There is no perturbation, right? So E3 will be simply pi square h cut square by 2ms square. So which is the greater one? This is the greater one. E1 is greatest, then E3, then E2. So E1 greater than E3. Okay. Another question like this. It's just revision class, that's why I'm going very fast. V naught is minus V naught. L by 2, L, 3L by 2, 2L, 3L. Okay. En1 is how much? So again, if you see, the perturbations are here and here. So we will calculate that only. So En1 will be minus V naught into L by 2 by what is the whole length? Whole length is 3L. Okay. So length of perturbation by total length plus this one. Only the perturbation parts will add. Okay. This is your V naught plus V naught. So V naught into this is how much? 12 minus 3 by 2 is L by 2 again. So L by 2 by 3L. So if you see, these are actually same and opposite. So answer will be same. So the whole perturbation, you can see like whatever there is up, there is down. So like the whole perturbation is 0. Okay. This is perturbation. So energy correction, energy will remain same. Whatever the energy will be, it will remain same. Okay. Next question. So there is perturbation. It is equal to V naught sine 2 pi x by L. Okay. Again, your first order correction is asked. How will you solve it? See, psi gs is given. Psi gs is what? For like this is a 1D box of length L. Psi constant is 2 by L sine pi x by L. Yeah. So your EGS will be what? Psi gs h dash psi gs. So root over of integration. What is the length? 0 to L. Okay. Root over 2 by L sine pi x by L into V naught sine 2 pi x by L into root over 2 by L sine pi x by dx. That will give me 2 by L will come out, V naught will go out, 0 to L. Now this is sine square pi x by L by into sine 2 pi x by L. Yeah. Yes. So yeah. Okay. Sine square theta is what? V naught by L. Sine square theta is 1 minus cos 2 pi x by L to sine 2 pi x by L dx. Yeah. So 2 V naught by L integration 0 to L sine 2 2 pi x by L dx minus 0 to L integration cos 2 pi x by L sine 2 pi x by L dx. Yeah. So uh, now I have to do the integration. So 2v naught by L. So integration of this one is minus cos 2 pi x by L whole divided by 2 pi L 0 to L minus. I can multiply 2 divide 2 here and it will give me what? Sine 2 theta, that means sine 4 pi x by L, whose integration is what? Minus cos 4 pi x by L whole divided by 4 pi by L. Okay, and 1 by 2 is already outside 0 to L. So 2b naught by L uh, minus is there. So cos 2 pi is minus 1, cos 2 pi is 1, cos 2 pi is 1 by uh, by 2 pi by L actually. Pi by L minus cos 0 is also 1. So, oh, so this one will become 0. It's coming as 0. Okay, this one let's see. Okay, this one will also come as 0 because sine 4 pi is 1 and minus 0, that is 1. So this is also, so the whole one will be 0. Okay, yeah, this will be coming 0, that's why. Yeah. So I hope you understood this. Okay, these were the normal perturbations, okay, like 1D box, 2D box, boxes and all. Now let's have a look into our harmonic oscillator. What if there is harmonic oscillator and all? How will we handle that? Okay. How do we handle harmonic oscillator? How do we handle harmonic oscillator? See, um, we have to first write down some formula. First of all, the wave function of harmonic oscillator is 1 by root over of root pi 2 to the power n factorial x naught e to the power minus x square by 2x naught square hermite of x by x naught. Yeah. Okay. Now this is, you don't need to remember this much. X to the power n expectation value is 0 if n is odd. P to the power n expectation value is 0 if n is odd. P is a momentum. Okay. Now what is operation like position operator in harmonic oscillator? H by 2 m omega half to the power half a. Okay. So raising operator, this is lowering operator in harmonic oscillator. P cap is what? I h cut m omega by 2 half. Okay. A diagonal minus a. Alright. Now x square is how much? X square is h cut 2m omega 2n plus 1 and p square is how much? Mh cut omega by 2 2n plus 1. Now if x fourth is there x fourth h cut by 2m omega whole square 6n square plus 6n plus 1 p fourth will be mh cut omega by 2 whole square 6n square plus 6n plus 1. Okay, sorry, this is 3. 6n square plus 6n plus 3. Alright, 6n square plus 6n plus. That's what it is. You have to remember, you have to write it again and again to remember. Alright? Yeah. Now, what is lowering and raising operator? Raising operator means the one that will raise the value. Raising operator would be what? Root over of n plus 1, n plus 1. Lowering operator n, n minus 1. Yeah. Write a question about this. Suppose Vx potential is given half kx square. Okay. Suddenly, the spring constant changes to k dash is equal to k plus epsilon. Now find En1 is equal to how much? Now find En1 is equal to how much? Okay, right. Spring constant, that means it was like this. First it was k. Okay, then when we stretch it, it became k dash, which is actually k plus epsilon. Okay, so from here we can find perturbation. Perturbation is what? The real Hamiltonian minus like the this one. Okay, so your main Hamiltonian is p square by 2m plus half perturbed Hamiltonian, that is half k dash x square minus original Hamiltonian p square by 2m minus k x square. We know k dash is what? K dash is a k plus epsilon. So this, let's see, this is cancelled. Half k dash plus epsilon x square minus half k x square. Okay, is that alright? So k dash is k plus. So half k x square plus half epsilon x square minus half k x square. These two are cancelled. So half epsilon x square. Half epsilon x square is a what? This is a perturbation. X dash is equal to half epsilon x. Okay. So now find first order correction. First order correction we know En1 is equal to what? Sine h dash sine. That means expectation value half epsilon x square. We don't do the integration. See how will we do it? Expect. Now if you remember the expectation value x square for the simple harmonic oscillator is what? Quantum harmonic oscillator h squared by 2m omega 2n plus 1. This is ground state. If this is ground state, energy correction half epsilon h squared by 2m omega. Ground state in harmonic oscillator n is equal to 0. Okay. So epsilon h squared by 4m omega. This is a ground state condition. Yeah. Suppose it is given h dash is given alpha x4. What do you do? Simple again. En1 is equal to alpha x4. That is alpha expectation value x4. That is alpha h squared by 2m omega to the power square 6n square plus 6n plus 3. For the ground state n is equal to 0. So your E01 it will be alpha h squared by 2m omega whole square into 3. Is that right? 3 alpha h squared by 2m omega square. Okay? Yeah? That is the answer. Next, so harmonic oscillator, you can do this. Another, suppose the perturbation is S gas alpha x cube. So En1 is what? Alpha x cube. This is how much? See, x to the power n expectation value is equal to 0 if n is odd. Simple. This will be 0. Okay. Next, this one is your harmonic oscillator. Next is your hydrogen atom also. Right? Suppose if hydrogen atom is asked, perturbation of hydrogen atom. So suppose the question is for hydrogen atom, sounds like H dash is equal to H, sorry, epsilon cos 2r by a naught. Okay, where a naught is the Bohr radius. So find out EGS, first order correction of ground state. So how will you do it? EG is what? Psi, psi h dash, psi. Okay. Now the ground state wave function of hydrogen atom is what? ZQ by pi a naught q root over e to the power minus r by a naught. Okay. So we'll just put it here. EGS1 is equal to ZQ by pi a naught integration e to the minus 2r by a naught. Okay, epsilon will go out. Cos 2r by a naught dr dqr. Okay, dqr because dqr. So I can write it as zq. Z is 1 for hydrogen. So epsilon pi a naught q. Mm, okay, root over is there. No. It doubly multiply. No? Okay, 0 to 2 pi. 0 to pi, 0 to infinity is e to the minus 2r by a naught cos, this is triple integration, 2r by a naught r square sin theta dr d theta d phi. Okay, so epsilon by pi a naught q sin theta d theta is your pi. This will give me 4 pi. Okay, the other ones. So what we have to exactly calculate is 0 to infinity e to the power minus 2r by a naught cos 2r by a naught r square dr. This is what we have to calculate actually. Yeah. Okay. Now the thing is cos 2r by a naught, I have to kind of open it a bit. 4 pi 0 to infinity e to the minus 2r by a naught cos 2r by a naught, I can write that e to the power I 2r by a naught plus e to the power minus I 2r by a naught divided by 2 r square dr. Okay. So this integration will go a bit longer and 4 pi epsilon naught pi cancel 4 epsilon by a naught cube 0 to infinity e to the power by 2 also goes out e to the power 2r by a naught I minus 1 plus 2r by a naught minus 2r by a naught I plus 1. This is r square dr. Okay, now it will be easy. 0 to infinity. Okay, we know the formula 0 to infinity if you know, otherwise write it down. E to the power m x to the power m e to the power minus alpha x to the power n dx is equal to 1 by n gamma of n plus 1 by n divided by alpha m plus 1 by n. Okay, So that will be 2 epsilon by a naught cube. It is in 0 to infinity, that will be 1 by n. 1 by n. N is how much? N is 1, or is n is 1. So gamma of 2 plus 1 by 1 divided by alpha. Alpha is this whole thing. 2 by a naught I minus 1 to the power n plus 1 by that is 3. Okay, plus gamma. Same thing here also. 2 plus 1 by 1 divided by minus 2 by a naught I plus 1, yeah, 3. Okay, so 2 epsilon by a naught cube, gamma of 3 is what? 2 gamma 2 2, gamma of 3 is 2, and this one remain as it is, a naught cube I minus 1 whole cube plus gamma of 2 divided by minus 8 by a naught cube I plus 1 whole cube. Yeah, this is it's a bit tricky here. And this a naught q can be cancelled out, right? 2 8 is 4, this is minus 4. Hmm. So 4 will go out, 2 epsilon by 4, 1 by I minus 1 whole cube plus or minus 1 by I plus 1 whole cube. Yeah, let's see. Epsilon by 2, I square minus 1 whole cube, I plus 1 whole cube minus I minus 1 whole cube. I square minus 1 is minus 1 minus 2, 8, minus 8. So epsilon by minus 16. Now this one is what? AQ minus BQ. A minus B whole into A square plus AB plus B square. Right? Yeah. So uh, minus A plus 1 A square. Oh, A square also have to calculate. That will be 2I plus AB, that is minus 2 B square minus 2I. No, cancel out. Minus 2, this is cancelled out. 2 2 2 minus minus 4 epsilon by 4. Okay, if you calculate this, answer will be epsilon by 4. So it's a very good question, like AGS 1. Hope you could do it. Try to do it on your own, because this calculations you have to do on your own in the exam also. Better to have a practice. Alright. So this type of question also come. H dash is equal to epsilon a dagger a whole square. Okay. So again, EG is 1. We have to calculate. So EG is 1. EG is 1 is H dash expectation value, which is epsilon expectation value of a square. Sorry. Okay. Which actually I can write a dagger a, right? Okay. This I can write it as, see very carefully. This I can write it as n. This I can write double. Yeah. Okay. Now I will slowly do it. We know in the right side you can write if you are confused. We know this is the raising operator n plus 1, n plus 1. It's the lowering operator n minus 1. Okay. So epsilon, this is n, a dagger, a dagger. Now I will operate this. This will be a root n minus 1. Now epsilon n. Now let's take this root n out. This one, okay? It's not needed. So I can write it. I will do slowly. Okay? So root n epsilon. Now I will operate this. Now this is a raising operator. Okay. So it will be n minus 1 plus 1, then n minus 1 plus 1. Yeah. Root n epsilon. Uh, Again, this is root n, so take it out. That means it will be squared. A dagger a n. Okay. So now n epsilon. Uh, Again, I will operate this a dagger. This is n minus 1 n epsilon. This is now I will take this out. Let's take this out. Now this is only left a dagger n. Okay. Now n epsilon. This is how much? This is again n plus 1 root over n plus 1. Wait, wait. This is n minus 1. Huh? Yeah. So it will be what? Root over of n minus 1 plus 1, because this is n minus 1 and it's a raising operator. N minus 1 plus 1. So root n epsilon n. This is a what? This is what? Root n. This is n. So root n now goes out. Root n into n epsilon, and inside n is 1, right? So this is n into n square epsilon. Okay, that will be the answer. This type of question also comes in exam. Yeah. Okay. Also, like question comes like there are eigenfunctions are given. Eigenvectors 1 0 0 1. Okay. Total Hamiltonian. Total Hamiltonian in presence of perturbation. Total Hamiltonian in presence of perturbation. H is equal to E1A E2. So what is the ground state energy correction? Okay. So H is equal to H naught plus H dash. Okay. And H naught I can write as E1 0 0 E1. H dash is the remaining. So remaining one 0 A 0. Okay. So H dash is 0 A 0. So E1 will be, I can write it as like this 1 0 0 A 0 and 1 0. The ones that are given. Okay. So I'll just multiply it. Let's multiply these two first. 0 this is A. This is 1 0 0 0 0. So answer is 0. So energy correction is 0. Okay. This was a time independent like perturbation. Time dependent is not necessary. We won't do it. Okay. Just write one more formula that is relativistic. Relativistic energy correction. Relativistic correction to kinetic energy actually. Kinetic energy. Relativistic correction to kinetic energy, that is En1 is equal to minus 1 by 8 m naught q c square mh squared omega by 2 whole square 6n square plus 6n plus This is the relativistic correction to kinetic energy. Okay, relativistic correction to kinetic energy is En1 is equal to 1 minus 1 by 8 m naught q c square mh squared omega by 2 whole square 6n square plus 6n plus 2. Yeah. What is the second order correction formula? Second order energy correction. Second order energy correction formula is what? En2 is equal to summation m not equal to n m h dash n square by En minus En. Okay, this is the second order energy correction. I hope it won't be that helpful because like second order doesn't come that much. But still, to safely remember it. There is another potential that is called delta potential that is also there. Delta potential. Delta potential is what? V is equal to minus alpha del x. Okay, so psi x is equal to m alpha by h squared e to the minus m alpha by h squared square and x. And your energy is minus m alpha square by 2h squared square. This is your delta potential. Okay. Hmm. So your question will be your delta potential is given minus del x. Suppose alpha x is given. Sorry, your wave function is given as a e to the minus alpha x, and perturbation is applied bx square. So what is the first order energy correction? Ground state. Okay, that will be the question. So again, how to do it? See, this is not normalized, so we have to kind of how will we write it? Psi h dash psi ground state divided by psi g. We are writing this because this is not normalized. That's why. So integration minus infinity to infinity a to the power minus 2 alpha x into bx square dx divided by this is a square integration minus infinity to infinity a square e to the power minus alpha 2 alpha x dx. Yeah, is that right? So a square b square is eventually, luckily, they are cancelled out. So b goes out minus infinity to infinity e to the minus 2 alpha mod x square dx divided by minus infinity to infinity e to the minus 2 alpha mod x dx. Now see, mod x. Mod x is x when x is greater than 0, is minus x when x is less than 0. Okay, so b minus infinity to 0 is the minus 2 alpha minus x dx square is there plus 0 to infinity e to the power sorry x square e to the power minus 2 alpha x dx. Okay, whole divided by minus infinity to 0 e to the minus 2 alpha minus x dx plus 0 to infinity e to the minus 2 alpha x dx. Yeah, is that right? So b that will be See, okay, minus infinity to 0 x square 2 alpha x dx 0 to infinity square minus 2 alpha x dx divided by minus infinity to 0 dx. Okay. Now the thing is, see what can we do here? We can change the limit of the integration 0 to infinity. For that we need to change the this one. So what will I do here? See, I will do x is equal to minus t, dx is equal to minus dt. Now the limit minus infinity will change to infinity and 0 will be 0. Okay, so the limit will be infinity to 0. X is t square e to the power minus 2 alpha t minus dt. Now the thing is the minus that will go out of dt, right? This minus can change the limit again. That will be 0 to infinity t square e to the minus 2 alpha t dt. Now I can see this thing is also equal to, I can change the variable inside and keep everything intact. That is the rule of integration. Okay, so eventually this thing has become this. Okay, so I will write it. So b integration 0 to infinity x square e to the power minus 2 alpha x dx plus 0 to infinity x square e to the power minus 2 alpha x dx. Okay, and the below part also, below part is not necessary. I can directly take the integration here. E to the power 2 alpha x by 2 alpha minus infinity to 0 plus e to the minus 2 alpha x by minus 2 alpha 0 to infinity. Okay, so now this becomes b 2 0 to infinity x square e to the power minus 2 alpha x dx. Integration, this is 1 by 2 alpha minus 0. Okay, plus 0 minus minus 12 1 by 2 alpha. So that becomes, you have to do it first. Okay, I'm doing really fast because I need to see 0 to infinity x to the power m e to the power minus x to the power n dx is equal to gamma m plus 1 by n by alpha m plus 1 by n, and there is a 1 by n here. Okay, so if I do this here, 1 by n, this means 1 by 1 into gamma 2 plus 1 by 1 whole divided by alpha is 2 alpha. 2 alpha to the power 1, 2 plus 1 by 1. Yeah, so that will give me 2b gamma 3 is 2 divided by 2 alpha to the power 3. Okay, 8 alpha cube. So this will be 4 2. So b to the power 2 alpha cube. B to power 2 alpha cube is the numerator, denominator is, and there is another b also here, and the denominator is 2 by 2 alpha. Yeah, is that right? So 2 to cancel, alpha alpha, this is alpha square. So b square by 2 alpha square. Okay, b square by 2 alpha square will be what? Will be your CGS one. I hope that's correct. If anywhere there is a mistake, please let me know in the comments. Okay, so this was a perturbation for delta potential. So just write some Hermite polynomials in case it comes in exam. Just in case. H1 not y is equal to 1. H1y is equal to 2y. H2y is equal to 4y square by 2. H3y is equal to 8yq minus 12y. H4y is equal to 16y fourth minus 14y square plus 12. This is some Hermite polynomial. Just, just write. Now another type of question can come. It will be like written in form potential V x y z is 0 infinity, 0 to x to a, 0 to y to a, when it is 0. Infinity is otherwise. Okay. Now h dash is what? V naught when 0 to x to a by 2, 0 to y to a by 2, and 0 otherwise. Okay. So you are asked again EGS1, E1. Yeah. So see, we have to see this is like a cubical well, and from here in x-axis 0 to a by 2 is perturbation, 0 to y a by 2 is perturbation y-axis. There is no perturbation in z-axis. So how can I write it here? See, first of all, the wave function is xyz 2 by a sine nx pi x by a, because all the lengths are a. 2 by a sine ny pi y by a, 2 by a sine nz pi z by a. Now the perturbation will be applied. So EGS1 is psi h dash psi. So when we see x-axis 0 to 0 to a by 2, why? Because the perturbation is between 0 to a by 2. V naught. Okay. So root over of 2 by a sine nx pi x by a v naught into root over of 2 by a sine nx pi x by a. Got it? Yeah. Into integration y-axis 0 to a by 2 root over 2 by a sine ny pi y by a v naught root over 2 by a sine ny pi y by a. And z-axis there is like no perturbation, so I can simply write z-axis as 2 by a sine square nz pi z by a. This is your dx dy dz. Okay, so whatever what things will be going out, uh, and if for z the length would be what? 0 to a, and this root over 2 by a is multiplied 6 times. 3 times. Let's take it as 6. Okay, 6 and 0 to a by 2. V naught is noted twice. Okay. Oh no, V naught will be once. No. Okay, get it. Yeah, only once here. Like only once it will be there. Okay, in the whole integration. So sine square pi x by a. This is ground state, so nx, ny, nz are 1. Dx is 0 to a pi z by a. So that. So this is what it is. Okay. So this is 2 by a whole cube v naught. This is 1 minus cos 2 pi x by a by 2 pi by sorry by 2 dx 0 to a by 2 0 to a by 2 1 minus cos 2 pi x 2 pi y by a. It's like that. Okay, the integration will go on like that. We have done this kind of integration, so I hope you can do this. Okay, so this is what your perturbation was. Okay, everything about perturbation we did, so I hope you understood. Next, write down. Next is the variational method. Variational method is also there. Just the process will write variational method. In variation method, what we have to calculate is EGS is equal to H minimum. Okay. So what are the steps? First of all, step one. I will just write the steps and do one question so I will understand. Step one is what estimate normalized trial wave function. Trial wave function. That is psi x is equal to whatever given. A e to the power minus bx squared. Suppose is given. This is called a Gaussian wave function. And a will be here 2b by pi whole to the power 1 by 4. Just remember it. Suppose in case it comes. Step 2. Step is find expectation value of Hamiltonian. Find expectation value of Hamiltonian. That means H. Okay. Then also of kinetic energy, also potential energy. So we can write H is equal to kinetic energy plus potential energy. Okay. Now do what? Step 3. Minimize expectation value of H with respect to adjustable parameter B. That means dH by dV is equal to 0. Okay. Now B is equal to B1, B2. You will get B is equal to B1, B2. Now just find d square H by dB square, whether it's positive or not. Okay. If it is positive at B is equal to B1, then we can just EGS is equal to H, B is equal to B1, which is H minimum. Okay. That's the process. That's what the process is. Just write down Gaussian trial function. Gaussian trial wave function. That is psi x is equal to a to the power minus bx square. A is equal to what? 2b by pi to the power 1 by 4. And your kinetic energy will be h square b by 2. And this is remember. Okay. This is for 1D. For 3D Gaussian wave function, psi r is equal to a to the minus e dr square. So a will be what? 2b by pi 3 by 4. So t will be 3h square b by. Yeah. Is that right? Okay. Yeah. Suppose an example is there. Example Vx is equal to half m omega square x square. Psi x is equal to a to the minus bx square. We know kinetic energy, we just wrote h square by 2m. We don't need to calculate. Okay, and a is what? 2b by pi to the power 1 by 4 e to the minus bx square. Right? So what will you do now? We need what? H is equal to t plus v. So we don't have v. V we will calculate how? See, v is psi, v psi. So if we do that, that would be minus infinity to infinity e to the power minus a e to the power minus bx square v a e to the power minus bx square dx. Okay. So v is a what? So a is a what? 2b by pi. 2b by pi to the 1 by 2 because double multiply double. Okay. So now v is a half half m omega square x square e to the power minus 2b x square dx. So 2b by pi to the power half m omega square, okay, integration minus infinity to infinity x square e to the power minus 2b x square dx. So that will be 2b by pi to the power half m omega square. So this will be, see, this is an even function, so I can multiply 2 and 0 to infinity x square e to the power minus 2b x square dx. So m omega square 2b by pi to the power half. Okay, 0 and this answer will be 1 by 2 gamma m plus 1 2 plus 1 by 2 whole divided by alpha 2p 2 plus 1 by 2. Yeah. So m omega square 2b by pi to the power half. This will be half gamma 3 by 2, that is root pi by 2 divided by 2b to the power 3 by 2. Yeah. So this is what it is. Yeah. This is it. 5 by 4. 5 by 8. M omega square root pi gone. 2b to the power half. This is your 2b to the power 3 by 2. This is 1 by 4. This is 2b. So m omega square by 8b. Okay. So your total energy Hamiltonian is kinetic energy excitation plus potential energy, that is h cut square by 2m plus m omega square by 8b. Okay, now we have to minimize it. Del h by del b is equal to 0. Let's see. So del by del b of h cut square b plus 2m plus m omega square by 8b is equal to 0. So h cut square by 2m minus m omega square by 8b square is equal to 0. So h cut square by 2m is equal to m omega square by 8b square. That is b square is equal to m square omega square by 8 h cut square. So b is equal to, this is 4 m omega by 2. Okay. Now I will do what? I will put this b here. Okay. So h minimum will be h cut square b by 2m plus m omega square by 8b m omega square by 8b h cut square into m omega by 2h cut into 2m plus m omega square by 8 m omega by 2h. Gone, h cut is h cut. Okay, h cut omega by 4 plus omega 4 h cut omega by 4. That is h cut omega by 2. Okay, so this is your AGS. So if you see, this is actually the ground state energy of harmonic oscillator, isn't it? H cut omega by 2. So that's the beauty of variational method. We are getting this value through all these calculations. Alright? Clear? This was one example of variation method. I hope you can solve other questions. Variational method. Okay? Next I will move to WKB approximation. This is the easiest question that comes. Just one formula will help you. No need to go into the complete theory. So En energy value would be alpha n plus half h cut. Okay, root over of pi 2m alpha gamma 1 by small m plus 3 by 2 gamma 1 by small m plus 1 to the power 2m plus n plus 2. We have done numericals based on this in the previous classes, so I can check that. Okay. Okay. All right. This is the formula for it. You will be asked. You will be given E as something Hamiltonian will be given alpha x square. lambda x square. So find the dependence on lambda and x square. Lambda is your alpha, so put in place of alpha lambda, and x square square. This 2 is actually your n. Okay? Yeah, yeah, that will be the question. That will be the only way the questions will come from this WKB approximation. Let's just write another thing about WKB approximation. The walls, like, suppose this is like this. So here, this is called beta 1, that is pi by 4. Beta 2 is pi by 4. This is called non-rigid wall. Non-rigid wall. If the wall is rigid like this, then your beta 1 will be 0 and beta 2 will be 0. But what is the need of beta? But for that, the formula is there 1 by h cut x1, x2. This is the original formula. We don't need to remember this because question will be directly coming from that. Ex is equal to, but in case, beta 1 plus beta 2, where beta 1 is equal to pi by 4 for non-rigid wall. Okay, but this is 0 is equal to for rigid wall. That's it. That's what the concept is behind multiple approaches. हाँ मैं हाँ okay, just go through it. I'm just coming in 2 minutes. Okay, so this was a WKB approximation. I hope you have understood so far everything that we have discussed. Now I will just try to formulas for scattering, which come in examples. It's completely revision process. We cannot go into details. Okay, from scattering, so from scattering, there will be two formulas that are very necessary. That is, one is general potential. That is scattering amplitude for general scattering amplitude. This can also come under first Born approximation. Okay, no problem. F of phi theta is equal to minus mu by 2 pi h cut square e to the I q dot r, okay, v r d, that's it, dq dot. This is one formula. Another one is for central potential. Central potential, okay, scattering amplitude f theta phi minus 2 mu by h cut square cube 0 to infinity r v r sin q r d. Okay, so these two formulas. Also, there is a trick formula here. Suppose the central potential is given. Central potential, if central potential be VR is equal to B e to the power minus mu r to the power n. Okay. So n can be minus 1 0 or 1 2. These are the higher values of n, higher values of n, and these are lower values of n. Yeah. So for lower values of n, the formula will be for lower values of n. The formula will be what? N is equal to minus 1 0. What will be the formula? F theta is equal to C naught by q square plus mu square to the power n plus 2. But for n is equal to 1 2, the formula will be, it's a bit lengthy one. C naught by q square or mu square n plus 2. Usually it comes as the lower values, okay, don't worry. But still, it's better to remember C1 q to the power n minus 1 mu n plus 1 plus C2, just interchange, see, just interchange of power q to the power n plus 1 mu n minus 1, just like that. It's just a bit trick and nothing much. Okay. Another formula for scattering amplitude can be f of theta 1 by k summation L 0 to infinity 12 plus 1 e to the power I delta L sin delta L PL cos theta. Okay. This is for S wave and P wave. For S wave, L is equal to 0. For P wave, L is equal to 1. Right. Your cross section is what? It's actually the square of theta phi. Okay. So these are some of the important concepts from what we studied today: perturbation, WKB, variational, and scattering. Okay, I hope you understood, and this is very important for your exam. So I hope you understood, and keep tuned to the channel for more videos. Thank you very much.